Good morning everyone. I am Suguna Selvarani, Assistant Professor, Department of Mathematics, CPA College, Bodinayakanur. Today we can see about Laplace transforms. First, transformation. A transformation is an operation which converts a mathematical expression to a different but an equivalent form. For example, logarithm is a transformation that converts multiplication to simple additions and divisions to subtractions. Laplace transforms. Laplace transform is one such transformation technique that transforms a mathematical conversion from one way of thinking to another to make a problem easier to solve. Laplace transform was first introduced by the French mathematician Pierre de Laplace. He developed mathematics in astronomy, physics and statistics. He began his work in calculus, which led to Laplace transforms. He used this Laplace transforms in his theory of probabilities. Uses of Laplace transforms. It is used to find the solution to differential equations of both ordinary and partial differential equations. Its relationship to Fourier transform allows easy way to characterize the systems. It is useful with multiple processing in systems. Definition of Laplace transform. The Laplace transform L of a function f of t for t greater than 0 is defined by the following integral over 0 to infinity. That is, f of s is equal to L of f of t, that is equal to integral from 0 to infinity f of t into e power minus st dt, where t is real and s is complex. Condition for existence. The first condition for the Laplace transform is f of t must be continuous or piecewise continuous in closed interval a comma b, and second one, it should be of exponential order, that is limit t tends to infinity e power minus st f of t is equal to 0 or finite. We have some results of Laplace transforms, that is, if f of t is equal to 1, then the Laplace transform f of s is equal to 1 by s. And f of t is equal to e power minus at, then the Laplace transform of f of t is equal to 1 by s plus a, and f of t is equal to cos at, then f of s is equal to s by s square plus a square, and f of t is equal to sin at, then f of s is equal to a by s square plus a square. Similarly, we have some general results, that is, the Laplace transforms have general results to solve their problems. Example. We can have an example. Find the Laplace transform of f of t is equal to 1 plus sin 3t plus cos h 2t. So first we can apply the Laplace transforms for the given function f of t. So f of t is equal to 1 plus sin 3t plus cos ht. So L of f of t is equal to L of 1 plus sin 3t plus cos h2t. So it can be applied separately. So L of 1 plus L of sin 3t plus L of cos ht. So we can apply the standard results of Laplace transforms. So L of 1 is equal to 1 by s, and L of sin at is equal to a by s square plus a square. So here L of sin 3t is equal to 3 by s square plus 9, and L of cos h at is equal to s by s square minus a square. So here L of cos h2t is equal to s by s square minus 4. The inverse Laplace transforms. It is the wide variety of function can be transformed. The inverse transform L inverse of f of s is equal to f of t. That is, f of s is the Laplace transform of f of t. Then f of t is the inverse Laplace transform of f of s. The inverse Laplace transform. We can have an example. If f of t is equal to 4, then f of s is equal to 4 by s. So, if f of s is equal to 4 by s, then the inverse Laplace transform of f of s is L inverse of f of s is equal to f of t, that is 4. Properties of Laplace transform. The Laplace transform and its inverse are linear transforms, that is, the transform of a sum or difference of expressions in the sum of the transforms. Then L of f of t plus or minus g of t is equal to L of f of t plus or minus L of g of t, and L inverse of f of s plus or minus g of s is equal to L inverse of f of s plus or minus L inverse of g of s. Number 2. The transform of an expression that is multiplied by a constant is the constant multiplied by the transform. that is L of k into f of t is equal to k into L of f of t, and L inverse of k into f of s is equal to k into L inverse of f of x. Thank you.